When questions on water of crystallization come up, they generally come in the form of an experiment. So you will have probably a setup, something like this in a diagram, Bunsen burner, tripod on top, and then you've got a clay triangle and a crucible. And this is one of the practicals that you will have done in class. We weigh the crucible empty, then we add some blue copper sulfate crystals to the crucible, and then we re-weigh the crucible now that it's got a bit heavier. Then we pop it on top of the Bunsen burner and heat it. And we heat it for as long as it takes until when we weigh the crucible again, the mass stops going down. So in the first few 5 to 10 minutes, we will see that the mass, the weight of that crucible will decrease. And then we keep heating it until the mass stops going down. In other words, we get 2 or more masses, weights that are the same. And we need to write all that information down in a table like this one. So let's start and have a look at some of the masses that we might record as part of this practical. Let's say that the empty crucible, the empty little pot, weighs 20 grams exactly. And then we spoon in some blue hydrated copper sulfate, and we measure the mass of the crucible again, and we find it's gone up to 22.50 grams. Then we pop that on top of the Bunsen burner and we heat it strongly. And then after about 5 minutes, we're going to weigh it. And then we're going to heat it a bit more and weigh it again. And we're going to keep repeating that until the weights that we get, the masses that we get, stop going down. So after about 10 minutes of doing that heating and weighing and heating and weighing, we find that the mass has stopped going down and it's fixed at 21.59 grams. And we can't get it to go down any further than that. So that's great. Now what we want to do is work out, well, how much actual blue crystals did we start with in terms of mass, and how much white anhydrous did we end up with? So to do that, we're going to do 22.5 minus 20, which gives us 2.50 grams at the start. And we're going to do 21.59 at the end, minus the weight of the crucible, which gives us 1.59 grams of anhydrous salt. And that's actually really useful and important because the 2.5 grams is the mass of this substance here with the H2O. And the 1.59 grams is the mass of the anhydrous salt that's left over. So if we started with 2.50 grams, we went down to 1.59, how much water was lost and evaporated during that process? So we can just go 2.50 at the beginning, ended with 1.59. That means that we must have lost 0.91 grams in that process. And that 0.91 is the water here. So that's the mass of water. And just to check, what it's always a good idea to do is see, do these two numbers here add up to what you started with? And indeed they do. So this is 2.50 grams. The mass of the reactant was 2.50 grams. So all of the mass is accounted for and nothing. The mass of the reactant should always equal the mass of the products. So the purpose of doing all of this is to work out what is the value of X here. How many moles of water are in that hydrated blue substance on the left-hand side? And the way that we're going to do this is I'd highly recommend you use a table. And the good news is that the table setup is very, very similar to the type of table you would use in an empirical formula calculation, except we're going to have the products of this reaction in the headings of our column. So we're going to have CuSO4 here, and we're going to have H2O here. And this is the anhydrous, or the dry copper sulfate. And the first thing that we know about both of these substances is the mass that we ended up with. So we know we ended up with 1.59 grams of this, and that we ended up with 0.91 grams of this. And the next thing that we want to do is say, well, how many moles do we have of each of those substances? Now we need to do another step in order to be able to work out moles, because if you remember, to calculate moles, we're going to do number of moles equals mass divided by MR. But we don't have the MR for copper sulfate and water. So I'm just going to do some quick sums at the top to work them out. Okay, so there you can see in red. So there's 1 copper, and I got these numbers from the periodic table. So the mass number of copper is 63.5, and the mass number of 1 copper is 32. There are 4 oxygens, so it's 4 times 16, and the total is 159.5. Water is H2O, so 2 times 1 plus 16 equals 18. So let's calculate moles for both of these substances. So number of moles equals mass divided by MR. So we have 1.59 divided by 159.5 that we worked out, and 0.91 grams divided by 18. And work that out in the calculator. 0.099 and 0.0505 are our moles. Now, the next thing that we want to do is we want to divide both of them by the smallest in our next row on the table. So we have 0.0099 divided by 0.0099 and 0.0505 divided by 0.0099. Working that out, we get 1 and 5.1. And this gives us our ratio. So we know that for every 1 mole of copper sulfate, there are 5 moles of water in this compound. Yes, you can round 5.125 in a water of crystallization compound. And that 5, so there's a 1 here and there's a 5 here, that 5 is the value of X. We have answered the question, what is the value of X in this formula that we started with, by following these steps and completing this calculation.